Yeah, that's good.
You're recording?
Yeah.
Okay, awesome. So I'm going to try to join in near the end
Okay.
and then answer questions, okay?
All
All
right.
right, great. So, before you go,
Yeah, I'm good to go.
can you screen share and all that?
Yeah. Let's see here. Share screen.
Now, there's not that many people. I see Alaska's on. There's not that many.
Mhm.
Malcolm. But I really want, I'm going to record this and use it as a reference, okay, Drish?
Yeah.
If people are not on, it doesn't matter. All right, great. Thanks, man. All right, bye.
Okay. All right, so I'm just going to go ahead and get started. So I have a short presentation here, and then I'm going to run through an example in Stata so you guys can see in live time exactly how it works. So, I'm going to talk about missing variables and imputation for missing variables. So first, what are missing variables? So for the purpose of this class, missing variables are continuous variables with a less than 100% entry completion. So as you can see from this image, it's, all those like missing dots in the variable. So for this lecture, I'm going to be going through cold ischemia time for kidneys as the example for the missing variable. And why we care about this is because with missing variables, we have bias in data, so it might not represent, the full set of data. And it can lead to difficulty in analysis, especially if to make a decision on what to do with those missing data points. If you have to, leave them out or like compare them with another data set that has a different number of variables, it can make, computation very difficult and inefficient. So in order to tackle this problem, we use a method called multiple imputation. So today I'm going to be talking about a specific method called predictive mean matching. And with this, the basic idea is to fill in the empty spots in the variable data set while preserving the mean and distribution of the data. So I'm going to try to, kind of give you a quick example of how this works. I don't fully understand the math behind all of it, but I think it's always good to, have some sort of concept of what you're doing before you just, run some code. So if you follow my mouse here, we have three data sets or three variables, A, B, and C. As you can see, B and C have a complete data set, and A is missing. So what this predictive mean matching does is it will run some sort of regression and create a relationship between three variables, A, B, and C. Now, in real life, there may not be any relationship between these things, but with this model, it assumes that there's a relationship and will create a logistic regression. It'll then calculate this equation over here, which is the expected value of A given B and C. So as you can see here, for this missing variable, it says the expected value is 0.6 and given based off the data B and data C. So what it then does, if you move over here, is it looks at the closest value to 0.6, which is 0.62. Now, this expected value doesn't really mean anything because it's just creating some number based off some relationship that may or may not exist. But what is most important is the actual value of A for the closest value of the expected equation. So the expected says the closest value to 0.6 is 0.62, and the real value of A for that is 0.24. So what this program does is it then just puts 0.24, or the nearest neighbor value, as the missing data point. So as you can follow here, the missing value then becomes 0.24. Likewise, for the bottom example here, with this missing point, it outputs 1.2. The closest one's 1.24. And the real value for 1.24 is 0.89, so it'll just put in 0.89. Does that make sense? Yeah. It's like, I think idea-wise, not super complicated, but like mathematically, I don't really know what's going on there, but I think that's a bit beyond our scope. So to actually implement this program in Stata, it's only 3 lines of code. It's super simple. So the first line is mi set wide, which I think just sets up the imputation. Not really sure what else it does. And then the second line is mi register imputed, and then the variable you want to impute. So this is cold ischemia time I'm using for this example. And the final line is the more complicated line with all the inputs. So it's mi impute PMM, which is our model, which is predictive mean matching, the variable we care about, cold ischemia time, and then add 10 and kn5. So add is the number of iterations we want to do. So it'll keep doing this and try to optimize it. And 10 is a good number to pick because it's kind of a compromise between a good amount of iterations, and if you did more than 10, it could take your computer like a long time to compute. So it's kind of a good in between. And KNN is nearest neighbor selected. So I'll explain what that means. So in this previous example, when we found the expected value of 0.6, it only looked at 0.62, which is the single nearest neighbor. But you can change that to how many nearest neighbors you want. So let's say we picked nearest KNN of 2. It would look at 0.62 and 0.65. So this variable, this number, and this number, and it would choose one of those two to input as the new variable, as the missing variable. So from, I guess, the papers out there and everything online, a good KNN to pick is 5. So something between 5 and 10. A lot of people say 10 is too many. A lot of people say 5 is good. So I just went with 5 based off of what I've seen on the Stata web pages. So with those 3 lines of code, you should be able to impute any variable. And what the output is if you follow this box here, is it'll impute and it'll give you a new variable for each iteration of imputation. We only care about the final iteration, which is _10 _cold _ish time or kidney. And this is the supposedly best version of the imputed variable. So if you want to look at here, comparing the means and standard deviations of the original variable with the cold ischemia time for the imputed variable, the 10th iteration, the mean's pretty similar, standard deviation is pretty good. I don't know, like, I mean, as you can see, the first, second, third, and fifth iterations do a decent job as well, but we should just use the last one, is what the internet and the Stata web pages seem to tell us. So I guess one thing to note is that you should only impute variables that are directly from the UNOS database, so not like any variable you create, just something that's from the database itself. So now I'm going to talk about when to actually impute a variable. So first, you should run your univariate and multivariate analysis without imputation. So, just do it normally. But while you do that, I think it's important to note entry completion of variables. So for example, like I created a table like this after I run multivariate analysis, and I take these variables from the UNOS database, and I say, okay, how many entries are present? So for example, cold ischemia time, 5,800 out of 7,900 are there, which is about 72%. And it's a continuous variable, and it's something I care about in multivariate analysis. So then I'm going to impute them. So once you note the entry completion of variables, so anything that's less than 100% is a continuous variable, and you care about it in multivariate analysis, those are the variables you want to be imputing. Yeah, so then once you impute it, you can redo the univariate and multivariate analysis with those imputed variables, and that'll give you a better, I guess, a stronger data analysis and better statistical models. I'm going to, I guess, run one of these in real time so you can actually see what's going on. It might be a little hard to follow over PowerPoint, so let's run it through Stata here. Let's see. Do you guys have any questions right now? I know I kind of went through that maybe a little bit quickly, but
I mean, is there a point beyond which like there's so few variables filled in that imputing doesn't matter?
yeah. So I think, so I've had 2 different like sources of information. Dr. Rana says like if it's below like 2/3, it's not really worth it to impute. But everything on the internet has said like 50% seems to be a better approximation. I think for the purpose of this class, maybe 2/3 might be the number to use. Like for a few of my variables had less than 2/3 completion. And then what I had to do was just change my like drop criteria to make sure that I had better completion. That might have to be specific to your project. I would maybe ask Dr. Rana specifically, but for me, below 66%, he said it's not worth analyzing. Okay. Let's see. How do I share desktop too? Okay, can you guys see? What can you guys see right now?
Your screen.
The Stata, right?
Yeah.
Okay. First, let me open the database. Okay, so I've opened up my database, and now I'm gonna do my drop criteria just to set. Okay, so it's just running whatever. Okay, so now I'm gonna run my normal analysis through before imputation. So I'm doing my setting my cold ischemia times and the reference in the ranges, and then running the regression without imputation. Whatever. Okay, so it looks like, it looks like a lot of these variables are significant in univariate analysis currently. So that means I'd probably use them in multivariate analysis. But if we look at the entry completion, so we have 7,900, but only 5,800 are full. So that would mean if I want to use it in multivariate analysis, I would have to impute those variables. So in order to do that, I have set up these 3 lines of code: mi set wide, mi register imputed cold ischemia, and the mi impute line, which this, oh, let me take out the, okay, and this takes a bit of time. And if you're doing this for multiple variables, like it could, take 15 minutes to run your whole script. So this is just for one variable and 10 iterations of it, and it takes maybe like a minute. So we'll let it run. Yeah, I mean, it's not super complicated to impute. It's just can be a hassle sometimes to go back and redo your analysis. So are you back in Houston, Alaska?
Yeah.
Okay, so let's
Right now.
Okay, so you can see the variable list here. It created the _10 option, and that's your new variable that you should be using for your UNOS database. So what you do next is you recreate your reference ranges. Can you guys see my command lines here? Yeah, so I recreated my reference ranges with the new variable instead of the original variable from the UNOS database. And then once you do that, you create your new reference variables, then like you just run those through univariate and multivariate analysis. So I would run it through univariate again here, and then whatever significant I'd run through multivariate. And that's really about it on imputation. There isn't really, there are other methods of imputation, which I don't know the math behind all of that or when exactly I would use those. But Stata has a good, if you just Google Stata impute, and it has all the documentation on it. So if you really want to, go further into it and learn about all the different types, you guys are free to do that. Yeah, do you guys have any questions on any of this? Yeah, not super complicated. Yeah, so I can, I guess, stop recording here so this doesn't Thank you. Thank you.
Excellent work.
Yeah. All right, let's stop screen sharing. Okay.